Thanks for having me. I'm very excited to be here. The paper I'm going to present today, opt-in, opt-out. I think it's self-explanatory in the title. We're thinking about organ donation systems. Right? Should it be opt-in or opt-out? There's a conventional sort of early nudge answer to this, which is that an opt-out, changing the default to opt-out, should increase donation by exploiting inertia. Right? So that is actually in the old sort of book Nudge by Thaler and Sunstein. Obviously, in the new book, they actually changed their position slightly, which reflects closer to the view that is in this paper. So I'm excited to get to that point. The argument that we make is is that this answer of just switching to opt-out in the old Nudge world is incomplete because relevant outcomes is not registration. It's the cadaveric donation of organs, and the outcomes is mediated by families, hospitals, and legal environment. So today I'm going to show three things before I actually get into this. One is I'm going to show cross-country policy changes and the fact that they actually do not produce uniform opt-out gains. Second, we use a simple set of two-player signaling model to explain why. Third, I'll try to present a lab experiment that reproduces the relevant comparative statics, right? And so that's what we'll do today. Let me begin with the basic question of should society presume that people are organ donors unless they opt out, or should they have to affirmatively opt out? Actually, before I even do that, I want to quickly actually show my two co-authors. I'm very lucky to be working with Ayush Gupta and Yetong. So these are both my students. Ayush is my PhD student who just graduated this year, or is graduating this year. He's going to join actually Mannheim to do a postdoc. He's very available for hiring. If in the current upcoming hiring cycle, you guys looking for a good market designer or theorist, let me know. Ayush should be a fantastic, both a brilliant scholar and also a great, fantastic colleague to have. Yetong is my pre-doc currently, but he's going to start shortly in a few months as a PhD at Harvard as my students. So, great students, and I hopefully you guys get to meet them soon as well. All right. So let me start with the policy problem. Organ shortages are large and persistent. Right? In the United States, over 100,000 people are waiting for an organ transplantation, and thousands each year die waiting. And this is not a marginal shortage. Right? The second fact is that a lion's share of transplanted organs to address the needs of people who have let's say organ failure comes from deceased organ donors in the United States, and also in a lot of European countries. For some organs, for example, hearts and lungs, just hearts, living donation is not feasible. Right? So deceased organ donation or cadaveric donation is central to the allocation problem. The third fact around this sort of paper that I want to establish is that, it's informational. Most people do not clearly communicate their donation preferences to their family. And I'm going to show, someone will show a slide with the citation that show us this. This matters because at the moment when the donation becomes possible for deceased organ donation, the family is often asked to make or authorize the decision under grief, uncertainty, and time pressure. So already, before we get to legal default, we should think of this as a mechanism with multiple agents: the potential donor, right, the family or the proxy, and then some organ procurement authority. In the US, it would be the organ procurement organizations. All right. Okay. And so in different countries make different default choices. In an opt-in system, in the United States or in Germany, willing individuals need to register to become organ donors. So in Germany, you need to, fill out this card. And in the United States, we will go on the website, Donate Life, to actually register to be part of a registry. People who do nothing are not on the donor list. For an opt-out system, from sort of presumed consent system, like, France, Austria, and many other countries, everyone is registered by default, right? And unwilling individuals can remove themselves from the donor list by actively doing so. And the conventional wisdom is sort of straightforward from the old Nudge literature. Is that defaults are powerful. So opt-out should increase donation according to this sort of worldview of using default. And if the only outcome were organ donor registration, that would be nearly the whole story. But we focus on actual organ donation, right, instead of just registration. In actual organ donation, legal consent often interact with family approval and family non-objection. So once that second stage decision matters, the default also affects what information the family receives about the organ donor's true preferences. Okay, so have this fact in the back of your head because I'm going to distinguish the legal regime a little bit further based on how much this family decision actually plays a role in the actual donation itself. Note that here I'm talking about defaults and I have not explicitly addressed yet the so-called mandated choice or forced choice regimes, where some people proposed where you basically have an agency of the government or the organ donation authority basically force people to make a decision of whether they want to be yes or no as an organ donor. So I'm going to come back to this to address this slightly later, but know that I have that in the back of my head. Okay. So here's the sort of structure of the paper. First, I'm going to construct. We constructed a novel cross-country data set, which is I think the biggest cross-country panel data set of actual disease organ donation rates and study countries that switch from opt-in to opt-out. Okay. Second, we show that opt-out countries does not always increase donations. A key source of heterogeneity is whether the family can overturn presumed consent, overturn the opt-out. So whether you have what we call a strict opt-out regime, where the family cannot overturn, or weak opt-out regime where the family can overturn the presumed consent itself. Third, we develop a simple signaling model. Under opt-in, a willing donor can credibly signal willingness by registering. Under opt-out, failing to opt-out conveys much less information, right? Because it pulls willing donors with inattentive or passive individuals or individuals for whom the cost of doing a registration act is too costly. Finally, we test the model in a lab experiment. The experiment supports the basic mechanisms. Opt-in often produces equal or higher donation rates unless signaling cost is costly and family power, veto power is limited, right? So, and there's some other parameters that we need to think about. But roughly, that's our journey, our roadmap today. Okay, so I will pause for a second to see if there's any clarifying questions before I dive into the actual meat of the presentation. Okay. Okay, cool. Okay, so let me get into it. So I'm gonna start with empirical evidence. The empirical section has two roles. First, it documents the gap between registration and actual donation. Second, it shows the key heterogeneity, the weakness and strictness of the opt-out that I mentioned earlier, that motivates the model. Okay, so this slide shows sort of what Thaler and Sunstein called at some point the most famous picture in social science. This is a result from Johnson and Goldstein. That shows that opt-out countries, which are the blue bars here, have dramatically higher effective consent or presumed registration or presumed organ donor registration rates than opt-in countries, those little yellow bars. The fact that that made organ donation such a this is the picture that often they have another picture that shows they have a regression with a selected sample of countries that shows that maybe we're using regression, you see the actual donation is also a little bit different, but as you could see later on, maybe the just running an OLS, maybe we don't get the causality piece as well, and maybe with the better data we get a richer picture indeed. Right? This picture, by the way, made organ donation such a canonical example of defaults. I mean, there are a lot of nudge units that are being formed. They show this picture as a motivating fact often, right, to pitch to policymakers and so on. So if the question is whether people end up in the donor pool in paper, right, opt-out is enormously powerful. If you look at this picture and it tells you that. But the important caveat here on the slide is that registration does not always result in actual donations. Because we care about actual organs being donated and actually used as transplantation as an element of transplantation. Right? The registration variable is upstream of the outcome that we ultimately care about. So in organ donation, this distinction is especially important because the person whose organs may be donated is deceased. So the final decision is mediated by the institutions and the family members. All right, so here is sort of like maybe a slightly better picture. This is in our paper. Once you look at actual donations, the contrast is a lot smaller. It's not the blue and yellow bar where you have this huge gap. Again, this is just like the last one. This is just plotting its correlation. It's not so much causation. Opt-out countries, which are the black bars, do appear to have somewhat higher donation rates in the raw cross-section. but the difference is nowhere near as dramatic as the registration difference that you see in the last slide. So of course, right, as I mentioned, the correlation is not causation. For economists, I think this is a pretty clear thing that you would notice. Countries with opt-out system, could differ systematically from opt-in countries in healthcare capacity, transplant coordination, trust in medical institutions, and sort of certain cultural attitudes towards death and the body, or some other things, right? So Spain is the example that's the highest bar here. Spain is the example that often is raised that, well, they have a very different, system of transplantation and interaction between transplant, organ recovery institutions and the hospital. So they actually have this cross section is useful as a puzzle, right? Here's the takeaway that, but we should not use this as a causal estimate, right? To get closer to the causal estimate, we study countries that switch from opt-in to opt-out. I mean, you could, I think you could immediately sort of see where I'm going with this. This is certainly be an event study design, which, a lot of economists are going to be familiar with. The treatment group includes a bunch of countries that switch from opt-in to opt-out. I mean, we include in this sort of event study data panel where there are control countries for these countries that are in the treatment group, and they are these other countries in the same continent. So I require at least there are a few control countries that extend 2 years before and after 2 years after the policy change. So we have at least a little bit of time to build the pre and post policy switch. Okay. I want to note that this is still not a massive treatment sample, right? So we want to be careful with interpretation, but it gives us at least a structured way and a much better, I think, empirical design causal to get at the causal elements of whether switching to opt-out actually increases actual organ donation. Okay, and I would sort of preempt that the key empirical move that you will see in a couple of slides is that I will split out the reforms by whether the presumed consent is weak or strict, right? Whether this opt-out is weak or strict. So I'm not going to do this. This is the estimating equation. This is a standard event study specification, okay? So here is what you get when we pool all the switching countries that you saw together and along with their control groups countries. The effect looks modestly positive. If you look at this, after the switch, you see a little bit of, little dots above the zero, but then you see the confidence interval is basically riding. This is 90.5% confidence interval. It's sort of riding the zero, right? So so you have some sort of modest increase, which is very different. Obviously, think about this compared with the first yellow and blue graph that we saw earlier, which is this dramatic thing. This already should tell you that maybe we have to think about this question carefully, right? The main thing to actually see, as I will show, is the heterogeneity, right? Some countries appear to gain after opt-out, others do not. This suggests that opt-out, as I hinted so many times already, is not one uniform treatment. In particular, the legal label might hide an important institutional characteristic, which is weak or strict, right? Whether the family can block the donation or not, given the consent status. And so we define the strict consent countries as places where it is difficult for the family to block donation once opt-out applied. Right? In this group, we see a much clearer picture. If you see here that there's an increase in donation rate after the switch to opt-out. You could see that, on the right side of this graph. The interpretation is intuitive, right? If presumed consent is enforced, then default changes the family's decision problem. Okay, right? If it is like a strict consent regime, strict opt-out regime, so this opt-out actually make a difference here in the data. Refusing donation is no longer sort of simply maintaining the status quo, which means that overturning, it means actually overturning a legally meaningful presumption, right? So in strict opt-out regimes, opt-out can have real bite. This is what this picture tells us. Now, I want to contrast this with this picture, which are the weak consent countries. The coefficients are, essentially flat. You could see that how much it's just really a flat line. These are places where family can easily block donation or where hospitals continue to seek family authorization in practice. Think about the United States. By practice, all the organ procurement organizations actually approach families, regardless of the registration status. My family, let's say something happened to me, they will ask my family whether they want to donate my organs or not. Even if I have registered, right? If I've registered and I have indeed registered in the United States, right? I would have given informed consent. But An OPO in the United States, an organ procurement organization in the United States, would never actually recover my organs if my families do not authorize. Indeed, they would actually ask them to fill out a form where they would check, have to sign next to each organ to agree to donate, even if I have opt-in. They will pitch it differently. For instance, they would come to the family if the person has a registration status of positively having opt-in. They would say, oh, let's honor Alex's wishes and blah, 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 right? The talk track is different, but they will always ask the family. So it's a weak sort of consent regime in the United States. Okay. This, by the way, the contrast between this event study graph and the last one is the key empirical pattern, right? Opt out on paper does not necessarily imply opt out in the final allocation. Okay? If the family is still effectively the decision maker, then the default may not translate into actual donation. And as the model will show in the next couple of slides, opt-out might even remove an affirmative signal that would have existed under opt-in. Okay? So this piece of empirical evidence is sort of basically one of our first contributions, is to really get a very nice view of how actually there's empirically does it work, and when you split it up, you see interesting heterogeneity. Coincidentally, I'm not going to dwell on this too much. We check this strict versus weak pattern, and it's not just an artifact of two-way fixed effects under staggered adoption, where we did all this like Son Abraham, etc., and etc. And it's also not simply a room to grow, right? So that maybe the baseline levels are different when people switch policies, and the strict and weak contrast remains. And so the empirical takeaway is opt out can raise donations, but mainly when it's institutionally enforced, when it's strict. The next question, of course, is why is that so? And I mean, I don't need to convince this group that often in this case, when we think about markets, and the design of these markets, a theoretical model, will be helpful. So the model is intentionally simple. It's not meant to capture every detail of organ procurement. Its purpose is to isolate one key mechanism, namely default affects only not incentive, but also information. So I'll give you a picture here. Just think of this as a quick. Actually, before I go there, any questions with the empirical, with the observational data empirical part? Okay, we could chat more at the end of the talk too. So again, let me come back to this. This is the theoretical model section. So think of this game that I'm gonna present to you as a two-stage signaling game. Player one is the potential donor. Player one can register or not. Well, this is a person who's gonna die at some point before the family, and they will become an eligible donor. Okay, so player one can register or not register at some cost. Later on, player two, the family member or the decision proxy, observes that action, combines it with a prior they have about player one's willingness to donate, and decide whether a donation actually occurs. Okay, the key asymmetry is this, and this is intuition to anchor in your head. Well, first of all, before the intuition, if you look at these, this grade letter here, I mean, this is the empirical fact I mentioned earlier. Here's some citations that. Basically, most families actually have, that are approached for actual organ donations have no prior communication to the loved ones about the wishes. So they're using the priors, they're forming some beliefs, but these are not necessarily accurate about what that person's true type, what player one's true type is. Okay. Again, let me come back to this. Think about this model, right? This is the action. Step one, stage one, register or not. Stage two, player two decides to donate or not. The key asymmetry is this. In the whole model that I'm using this model to illustrate. Under opt-in, a willing donor can actively say, I want to donate, right? When we fill in this card, that's what I can do. Under opt-out, a willing donor typically says nothing. Someone for whom it's too costly to do anything also does nothing, okay? They're simply pooled with everyone who did not opt out. So the default affects the meaning of the silence itself. Basically, that's sort of the main intuition of what we want to think about in this model. Okay, so it's very simple, but I'm going to just walk through the model now. So formally, player one has type, has type D, little d, 0 or 1. 1 means that the person is a willing donor. Like I want my organs to be donated if I do pass away. Type 0 means unwilling donor, so that means the type of people who are unwilling to be donors. Player 2 does not observe the type, but knows the prior probability p, little p, that player 1 is a willing donor. You can think of little p in two ways, right? Either as the share of the population of people who truly wants to donate, or the family's prior belief about this particular donor's willingness. If you know perfectly, then little p just goes to the actual the actual type of need. Yeah. And so player 1 chooses an action S, 0 or 1. The interpretation depends on the regime here. So S is whether to send the signal. Think of this, the little s is the act of registration. Under opt-in, little s equal to 1 means that the person opts in. Under opt-out, little s equal to 1 means the person opt out. Taking this action of opting in or opting out has the action cost of little c. Okay. Player 2 observes little s and then chooses big D, 0 or 1. Right? 1 means the donation occurs. Player 2 face two costs. First, as an emotional cost of donation, epsilon. And second, a cost delta of overturning consent or presumed consent. Okay, so again, think about the little delta here. Oh, sorry, the epsilon here, the emotional cost. I say that it's bigger than 0 because maybe people don't want to donate. There's a cost, emotional cost of seeing your love. Think about your loved one getting cut open, or you have to fill out much more paperwork. But you could imagine this term also being negative, right? Meaning the cost is actually a benefit. People actually want to get a benefit from donating. You could think about this, and a lot of the results would still go through. But for purposes of the model here, think of it as like the cost of donation. Okay, so player 1 wants the final outcome to match their type. In other words, they want a big D, which is decided by player 2, to match their little d, which is their type. If the person wants to donate, right, they get utility when donation occurs. So for me, I get utility if the donation actually occurs. If the person did not want to donate, they get utility when the donation does not occur. The parameter x captures the value of having the outcome match the type. This can be interpreted as anticipatory utility. For a willing donor, it is the value of knowing that the organs will be donated. For an unwilling donor, it's the value of knowing that they will not be donated. The action also have a cost, right? Little c. So signaling is valuable only if the benefit, or sort of the expected benefit, from changing the outcome, right, exceeds the signaling cost itself. So that's what my decision criteria as player 1. Think, could the signal actually shift how the outcome would be, and could I bring it to be closer to what I want, so I get a little x, and then compare it with the cost of signaling. Okay. Player 2 wants to honor player 1's true preferences, but does not observe it. Player 2 receives benefit big X if the final outcome matches player 1's type. Donation itself carries this emotional cost that I mentioned, and blocking donation carry the cost of delta, as I mentioned also, depending on the regime and the signal. Under opt-in, look at the first equation here. If player 1 opted in and player 2 blocks donation, then player 2 pays the cost of overturning the express consent. Under opt-out, if player 1 did not opt out and player 2 blocks the donation, player 2 pays the cost of overturning the opt-out of the presumed consent. This is where strict and weak consent, right, enters the model. A strict regime corresponds to, think of it as the higher effective delta, right? Like a completely strict consent is the epsilon is just extremely large, going to infinity. A weak regime corresponds to a lower effective delta. Like a completely weak one is basically like, a delta equals 0, okay? So with this setup, I'm going to use the solution host I'm going to use to make the predictions about what's going to happen is a pure strategy-based Nash equilibrium. There's multiplicity, which is standard in signaling games. Okay? We therefore, focus on the sort of the intuitive equilibria that we could see in this game, where player 1 uses the costly action to communicate preferences when it's worthwhile, and then player 2 donates when the posterior belief that player 1 wants to donate is sufficiently high. Okay, we have a lab experiment later on, right, which will then help discipline whether these intuitive equilibria are behaviorally relevant. Okay, that's partly why we have lab experiment, and I'll mention why. There are more reasons, obviously, why we might have experiments for market designers now. This figure here basically puts the model described so far into a picture. This figure lays out the model's prediction over the parameter space. The horizontal axis is the cost of signaling little c. The vertical axis is player 2's prior little p. The panels here compares opt-in and opt-out. When the signaling is cheap, both regime can support separating equilibria, but the identity of the signaler differs. Right? You can see that the parts where the separating equilibria is essentially where the little p is donated. Under opt-in, willing donors can separate by opting in. Under opt-out, unwilling donors can separate by opting out. And you can see a region where there's a there are multiple equilibria in the top left box in opt-in. You can imagine that part being either you have the separating equilibrium where person signals that if I'm of the type that I want to donate, and then player 2 only donates if they see the signal. Or another equilibrium you can imagine is the priors are quite high here. So basically what happens is that player 1 would just not signal, player 2 acts according to their priors. And so here you can imagine this is the pooling equilibrium where everyone donates. Every player chooses to donate. But if you look at this picture, the asymmetry you observe here is a central theoretical point. Okay? There are two main cases. Think about the comparison here. I'll show you the picture again. So, first, when signaling is very costly, player 1 does not opt in or opt out for that matter. Then player 2 decides based on the prior and the default. Right? In this region, opt-out can increase donation because blocking coalition means overturning presumed consent. Okay? Second, when the signaling is cheap, opt-in can perform very well because willing donors can credibly identify themselves. Opt-out does not provide the same affirmative signal. And inaction under opt-out leaves the family asking, do this person actually want to donate, right? Or did they simply never get around, or it's too costly for them to opt out? So opt-out is not opt-in plus inertia. It is actually changing the information structure. Coincidentally, I should have actually make sure that I'm clear about this. I did talk about y-axis, why this x, the utility of getting for player 1 getting wishes met is x compared to the cost of signaling. This is where the one of the threshold levels are. But think about this as player 2 also have these two threshold levels. It's based on basically if the prior beliefs it has to be higher than a certain level, right? And that level is determined by what they get, how much emotional costs, how much hassle is to overturn, and so these thresholds are just you can imagine then saying how high of a prior belief do you have to be for you to take certain action. So I should have been more clear when I show you this, but I think the picture was intuitive enough, so a lot of people get higher priors, and I mentioned that earlier when the cost is too costly to opt in, opt out, people rely on the priors. Here's the clearest, right? Where if the prior is very higher, everyone's donating. If priors are low, people are not donating. Here's the opposite. Okay, so let's come back to here because now hopefully you spot something in the last picture when I re-showed it again. The intuition is simple. Under opt-in, the action I opted in, or the fact that I purchased the signal, is a very clear positive signal. Sorry for the confusion of the statement, right? But opting in is a very clear positive signal. It tells the family that the person affirmatively wants to donate. Under opt-out, the action I did not opt out is weak evidence. It pools willing donors with inattentive individuals, procrastinators, people who never saw this form or this card, people who simply did not want to think about death, or people in general that have high costs of registering. So opt-in produces at least P donations, little P donations when the signaling is cheap, because willing donors can say yes. Opt-out produces more donation only in a more specific region where the priors are moderate, signaling is costly, and the family faces a meaningful cost of blocking donation. This is the conceptual reason why strict opt-out can work, but weak opt-out does not work. Okay, so this is what I'm saying. Like you look at this earlier, right? If you compare these boxes, most of the boxes on this left side has a higher donation number than except this one here. High cost of donation, middling levels of family priors. Here's 0 to 100%, but everywhere else, right? Opt-in sort of weakly dominates opt-out. Okay, cool. Okay, so before I actually head to this, I did promise to talk about this, and this is important because I think if you are in the organ transplant space, you probably have thought about this a little bit. A natural response is why not avoid the opt-in versus opt-out debate entirely and just use mandated choice or forced choice, right? What we call mandated choice, forced choice. I think it's important alternative conceptually, and the model does speak to it in practice. In theory, if the choices were genuinely compulsive and perfectly enforced, then the signaling problem would be different, and we don't need to think about default, for example. But in the actual practice of policy, truly forced choice is very hard to implement. In fact, government are rarely able to compel every individual to make a binding organ donation decision, and politicians are often not interested in spending their political capital required to create and enforce a regime where you force people to make a choice. Right? Often what you see instead, and indeed what you see across the world whenever they try some sort of mandated choice or forced choice, is that you see some sort of prompted choice rather. For example, sometimes people are asked in a tax return, as a part of tax return, you answer a question. Or some other government interaction where they ask you whether you want to register. But in practice, this is not really enforced. Think about the tax form. People can still skip the question, fail to complete the form, and misunderstand the prompt or avoid the interaction altogether, right? So there is still a need for a default because if people did this, like what is their position of consent? From the perspective of the model, right? In this case, where in reality you still need some sort of default, many real world, the real world actually plausible mandated choice proposals are better understood as lowering the little c in our picture, the cost of signaling, rather than eliminating defaults. Right? That distinction matters because lowering the cost of signaling can make opt-out, opt-in work better because willing donors can more easily send an affirmative action. Right? It can also change behavior under opt-out, as you see in the picture, but it does not eliminate the core informational issue. Under opt-out, silence by a willing donor is still not an affirmative statement of willingness. So the lessons here apply directly to many real-world mandated choice proposals as well. Like emphasis on real world. In practice, they can often operate as a cheaper signaling opportunities layered on top of underlying default, not as a completely separate regime. So now I turn to the experiment, as I promised, the lab experiment, and I think I have around 10 minutes left. So let me see if there's a quick question, and then otherwise we have plenty of time, I think, at the end to ask questions before I go into the lab experiment. Okay, so this lab experiment is not a thing to replicate the emotional environment of organ donation. So that's not what the point is. The purpose is to isolate the strategic structure of the model. We talk about the equilibria. And second, as market designers well know, often lab experiments is a very good way, as Al Roth would put it, as a way to talk to the princess. I talked to policymakers. Indeed, I presented something like the intuitive picture of the model in multiple transplant conferences, critical medicine conferences to people who actually run national transplant programs. They only got it, or they really kind of bought into the intuitions after they saw these lab experiment results. So that's one of the other purpose. Okay, so I kind of mentioned earlier already. The model have equilibrium multiplicity, and the experiment helps us see whether the intuitive equilibria are behaviorally relevant. Second, cross-country evidence cannot randomly vary signaling, family priors, and veto costs. And the experiment, we could do that, right? We cannot experiment in the real world as much as we want to. Third, as I mentioned already, policy audiences often find mechanism clearer when it appears in incentivized behavior and not just in equations. I mean, I think most of the folks in today's virtual seminar love and as much as I do a nice theoretical model, policymakers tend to like pictures with an experiment and incentivized choice more. Okay, so the experiment is run through Prolific with around 1,000 participants taking around 18 minutes to do. Participants are assigned into treatments in a 2 by 2 factorial design. The first dimension is they're randomized into either just opt-in or opt-out regimes. Second is the cost of signaling. We don't have a continuous, we just have high or low. The third is the cost to the proxy of overturning consent, the cost to player two, whether it's high cost or low cost for them to overturn consent. Okay, so think about the strict. This is sort of the strict versus weak consent regimes. So the experiment directly varies the three objects that, remember the model, says should matter. Okay, to avoid the emotional and moral connotations around the actual organs and try to think about the prediction, the behavior prediction of our theory. The experiment uses a neutral object called a WUG, which I stole from the developmental science literature. Each participant is randomly assigned a type. A donor receives a bonus. Player two receives a bonus. Player one, the donor, receives a bonus if the WUG is donated. Right? If there's one type where they do that, right? This is they get 50 cents. The non-donor types, which is the other type, receives a bonus if the WUG is not donated. Participants then choose whether to opt in or opt out. Right? Once they figure out what they learn about the type, depending on the treatment, they decide to opt in or opt out, right? And they only get to choose one of these because they're randomized in 2 different treatments. And the signaling costs are either high or low, right? 0.75 or 0.25. Note that the 0.5, which is from from the last element, is in between the 0.75 and 0.25. If you think about our picture earlier, you basically are getting data on 2 sides of our graph. Okay? This 0.75 and 0.25 maps to the model's parameter little c. Okay, so the experimental design, each participant is then matched with another participant who acts as the decision proxy, player two. The proxy decides whether to donate the WUG or not, and they get paid for matching the owner's type. Player one's type pays a small cost if they donate, and may also pay a cost for overturning the default or the signal. We also elicit decisions under different values of little p. Right? The proxies believe that the WUG owner is a donor type. So the experiment lets us observe donation across the full grid of the picture I showed earlier: opt-in versus opt-out, and cheap versus costly signaling, weak versus costly consent, sort of in the middle, and versus intermediate versus low versus intermediate versus high priors. Okay, so here's some theoretical predictions. Using this picture again, this is for the treatment when the delta is 0.01. So think about this as the weak consent regimes. When the family can easily return the consent, the model predicts that moving from opt-in to opt-out should weakly reduce donations in part of the cheap signaling region, the region that's circled in red. The reason is the signaling asymmetry, right? Under opt-in, willing donors can affirmative action. Under opt-out, unwilling donors can opt out, but willing donors do not have a similarly strong affirmative action. So you can see it goes from P or 100% to P, or it goes from little p to little p or 0. So this should weakly decrease the donation. And if you look at the experimental data, you could see that that is indeed true. It's either insignificant or there's some sort of significant reduction. I'll put everything in one picture so you can see them much more easily. The other side of this picture is, when we look at the higher cost of signaling, in the high prior case, the donation is much higher under opt-in regime than the opt-out regime. Sorry, I meant here because the delta is very low. If you look at the top part and the bottom part, they should be the same on both sides. Right? This is when they're just going with the priors, and there's no signaling happening here. And the delta is low, so people could just overturn the consent to get to what they think is matching the donor. So they go with the priors. So this should be no change. And in the experiment, you do see sort of basically no significant difference between these things. Now, on this one, where we're thinking about the delta being higher, this is now we switch from weak consent regime to the strict consent regime now, right? In the weak consent regime, remember we see all the opt-in boxes being weakly higher than opt-out boxes, all of them that we see in the picture, right? Now we start with delta equals to 0.19, the strict consent regimes, and let's see what pictures we get. The first part is this top box and this bottom box highlighted in red here. When signaling is, when the signaling cost is not costly, you basically have um, opt-in can still do very well because the willing donors can identify themselves, right? It's not costly. So even the strict opt-out does not dominate everywhere. Although the thing that changed, so you can see here's the same as before. So the data is the same. Here, the middle box here on the left changed because here's because with a strict consent, well, with a consent regime changing, sorry, here on the left is where the because of the strict consent, the cost, the delta, the threshold of the priors you have for you to do the donation is now in little 0.41. Sorry, in 0.6. Sorry, it's higher because if you and so what you have here is that this middle box here, you basically have a similar situation where you have a separating equilibrium, so it's both a little p. On the right, the top box and the bottom box, you have the same story as before. But all of these three regions, what you should see in the experiment is that you should still see basically no difference between the two, opt-in and opt-out. So you should see weekly decreasing donation, which you see here, and you should see no change here, which is also true. This is the part that's interesting for the people who are advocating a switch to opt-out, which is, when you have high cost of donation, now the interesting thing is when the consent is strict, it's costly to do to overturn the consent. Then the consent only bites your decision when you are in an opt-in regime. Sorry, when you're in an opt-out regime. Because if you're in an opt-in regime, right, you will only consent if your type is truly the type that wants to donate. So me as player two, I would never want to actually overturn your decision at the time. So I don't eat the delta. But if you're in an opt-out regime, I didn't do anything. The willing donor would be also silent. But then you would have consent by default. So in this case, I have to eat this, this delta so that the cutoff of my donation, changes. Meaning, namely that the cutoff will be lower, right? My priors will be lower for me to overturn the consent and donate in the opt-out regime. So which is why you see this new region that gets essentially, which was part of the bottom, that gets eaten up by the top in the opt-out regime. Because in the opt-out regime, that's when the delta eats into that the decision itself. And then you would see this shift. And it goes from 0 to 100%. So the theory would predict that you should see a big increase here. It should be the biggest increase. And indeed, in the lab experiment, you actually see this result, which is quite neat. And then you do see what you expect here, that you see the huge increase there. And I didn't have usually I show a picture with all the numbers there. The other thing I want to mention, which I didn't mention here, is that once you look at all the numbers, that's the picture I show the policymakers, because they really like seeing that, to see, and I put red or green to see which one is changing. For market designers, this is especially nice, because if you show it to people making decisions, let me actually show not one without the numbers, but actually with the predictions. Imagine the numbers are filled out and as the predictions would be. You could not only just compare these boxes left and right to see, when you switch, where do you believe you are in the parameter space? And when you switch, would you get some gains from switching? The other thing that's nice is that with a switch to opt out, some things could also shift. For example, people might change their priors because now they think, oh, we're the kind of country that default people into donation. So I guess, we're the kind of people that actually wants to donate the organs. So maybe that shifts the priors too. So as you move from the left picture to the right picture, maybe you're not moving from the same box to the same box. Maybe what you're doing is that, you go from like this box here in the bottom to this box in the top. So you actually move from P to 100%. So you'll see an increase. The nice thing about this picture is that it allows you to see all of this. And for policymakers to just see this without having to do a lot of the reasoning with the model. So that's sort of I'm preaching to the choir, I think, because you're all market designers. But this is a very nice reason of why we want to do some lab experiments sometimes with our models to illustrate what's happening to the people who make decisions. Um, so to conclude, opt out typically does not increase the donation, as I've shown in the picture, right? I mean, they're often defaults are often described as changing decisions through inertia. This is a true statement, but often in this case incomplete. I think it's also true in the case of defaulting into savings. I think there's some recent paper by John Bashir's et al. That when they default people in savings, actually who have compensating behavior, they borrow money to spend or something like that. Right? Defaults here, in our case, the reason why the default turns out didn't work the way that we want them to is that they changed the information. They changed who can signal and what silence means and how downstream decision makers can interpret inaction. And organizations often give willing donors a positive signal. Opt-out gives unwilling donors a negative signal, but leaves the unwilling donors pooled with everyone else. So if family have discretion in a weak consent regime, the informational difference can undo the mechanical effect of the default. Okay, so the policy implication is not, right? It's important to think that it's not to never use opt-out. The policy implication is evaluate the whole mechanisms. Relevant objects are the default, the cost of signaling, the family priors, and the cost of overriding donors' apparent choice, which we have talked about in the model. There are other things that might matter, but for this mechanism we talk about, these are things that at the minimum we need to consider. Opt-out works best when it's institutionally real, when it's strict, when the presumed consent is enforced. Think about Austria in the 1980s or Singapore in the 1980s. There are cases where they would actually start recovering before they actually contacted the family when people have not opted out. And in weak consent environments, like the United States and basically every country now, because I think no country is implementing a strict consent regime anymore, simply changing legal defaults is unlikely to produce large gains. Policies that preserve or strengthen affirmative signaling lower the cost of communicating preferences, right? Like these, mandated choices or asking people multiple times. You have seen some recent work, for example, by Auroth and Judd Kessler, or make donor wishes harder to overturn, on the other hand, may be more effective. More broadly, this is a cautionary result for default-based policy design. A default can increase nominal participant rates while reducing the information content of individual choices. And mechanism is likely relevant beyond organ donation, as I mentioned earlier. In savings, you already see that. In any decision that requires like a proxy, later proxy court family members, like you think about wills and inheritance decisions and so forth, and requires some other player to make decisions and requires them to interpret someone's earlier silence. I would end by saying that England and Wales is a very nice story of this journey that a lot of scholars in this field or a lot of policymakers in this field actually went through. They are big early adopters of nudge units. So they actually adopted they switched an opt-out policy just around the time when nudge units are going all the rage. But I'm working with NHS for full caveat. I have colleagues who are working on organ transplant things. My colleagues in NHS rightfully find that after they pushed the opt-out, they didn't get much. If anything, the actual number of organs they got flatlined or reduced over the time period. So they actually switched back to a de facto opt-in policy by putting an opt-in on top of the opt-out, which really is an opt-in, except in the cases where someone died and you could not contact any family. That's sort of, that's the only difference. But they basically went through the journey of having to legislate twice to actually do this. And this paper is partly to hope that as market designer, hopefully this guide us to think about our thinking of how to think about these organ donation markets and potentially not make the mistake that NHS had made at some point in the past and having to sort of switch back to another regime. Cool. Okay, I will pause. Thank you so much.